Kévin Le Bon is going to present MLExplain.
Oui, alors, ok.
Yes.
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 So, hello everyone. I will present you MLExplain, a double debugger for Kévin, which is a project I developed during an internship at INRIA with the help of Alan Schmidt. So, first of all, I have to explain a bit the context of the project and then present MLExplain and its counterpart, JSExplain. Then the changes between the first one, JSExplain, to ours, and finally a little demo of the project. So, first of all, how can we define the semantics of OCaml? We have three main ways to do it. We can write a book or specification, just like JavaScript. We can formalize the semantic of the language, or use the official implementation as a definition, just like OCaml, for instance. Well, the problem is that it's hard to understand. Natural language is prone to ambiguity, and also books tend to be very long, just like JavaScript 1. Formalism requires some knowledge, and personally I won't be able to understand it. Also, official implementation are not meant to be easily readable to someone who tried to learn the semantics of the interpreted language. Because there are optimization, there are many things that pollute the pure execution of the language. So let's try something else. Could we use debugger on the interpreter to inspect the execution of the program? And the response is no. Because you will just look at the interpreter and have, so to say, no idea what happens in the interpreted program, because the access to the state of the program won't be direct. So we have a little solution, which are double debuggers. Double debuggers are a big program that contain an interpreter and interpreted program and can analyze both at the same time. Here is a little unreadable screenshot of our project, where we have a program that will be interpreted, the interpreter, at least its code, and you can see both the state of the program and the state of the interpreter at each step of the execution. So the advantages are that you can easily inspect both the program and the interpreter state. Another advantage is that the system will be specialized to the inspection of the interpreter and the interpreted language, with the interpreted program, which means that you won't have unnecessary information that classical debugger will give you because they are generalist. It will be aware of the AST and the program state's internal representation. That means that you will have even more precise information of what is happening. You can print it way better. And also the representation of the value are known by the debugger, so you will have the prettiest printing ever. So what is MLExplain? It is a double debugger for OCaml. It doesn't come from nowhere. It is an adaptation of JSExplain, which is a double debugger for JavaScript. The main goal of our project was at first to prove that the JSExplain system could be easily adapted for another language without having to re-implement the whole structure. So I will present what are in common in both. First of all, they are a web application. So that means that we have a web interface where the user can interact with the system. The web interface will give the code to execute to our interpreter that creates traces of the execution. And we have a trace controller, which can be thought more or less at the back end of the application, which handle the traces and interact with the front web interface to manipulate the trace and provide output information. The web interface and trace controller are written in JavaScript, because web application, while the interpreter is written in OCaml and compiled to JavaScript. our web interface is, as I mentioned before, we have the interpreted program, its state, the code of the interpreter, and its state. And at the middle, we can have different controls to interact with the execution of the program to specifically look at what is happening during the execution. Let's talk about the code. Both are written in a functional subset of OCaml, which we named FOCaml. It is compared to a functional subset of JavaScript. The reason is because we need to integrate it into our web application. And we are using a homemade compiler, which we named Generator. The reason is that we need to annotate the code of the interpreter during its compilation, so that it inserts different commands to log what happens during the execution. These log commands are what generate the traces. So FOCaml is a very minimalist functional subset of OCaml. It only includes the essential part of the language to handle our job. So the downside of it is that it lacks features of OCaml, and especially interaction with OCaml libraries, which will give trouble later in the process. And because of all of this, FOCaml code can be quickly verbose and hard to understand. For instance, we use monadic combination to handle errors both in the interpreter and the program during the interpretation. So if you had to write your combination as is in FOCaml, it would look like this, which are the combination operator and the concatenations. But we have used BPS extension to make the code much more readable, and what is here and disgusting ends up here with a much more readable code and much more natural to us. So at first we had JSExplain, and what did we have to change to obtain MLExplain? So the main modifications are the interpreter, because we don't want to interpret JS anymore, and only some parts of the trace controller, and these are the parts that handle OCaml values. So we have the pretty printing and the trace navigation. To sum it up, only the language-specific parts of the system have been changed. In our interpreter, we don't put everything in the same binary, which means that we separated the front end, which is the parsing and the typing process, with the pure interpretation of the program, for two reasons. The first one is that the execution will be traced, so we compile the interpreter with Generator, and everything is written in FOCaml. And the front end, we don't want to trace it because it has nothing to do with the actual interpretation of the program. So we put it away, we write in plain OCaml and use JS of OCaml to compile this part. We use the compiler libs to make the parsing and typing process, because it's the same front end of the official compiler, so we are sure of the output. In our figure here is our system. You have in red the front end. Our interpreted program is parsed and typed in the front end compiled to JS of OCaml. We obtain an AST, which is translated into another AST representation that our backend can understand. We have our backend compiled using Generator. Generator has two modes of compilations. One with which generates traces, which is what is called the tracing compiler, and another that doesn't, because we don't want auxiliary code to be traced, so that the traces end up simple to follow for someone who doesn't understand the semantics of the language. And this backend generate the traces of execution that can be used later the web interface. As I said, we type the program in the front end and we make the name resolution, but why though? Because many of the features of OCaml are very difficult to interpret right from the parse tree, among them the label parameters and the optional parameters. Here is a little example. In fact, we learned during the developments that in OCaml, total application of functions are not just partial applications until there is nothing more to reduce, because of these label parameters. In fact, if you make a total application of the function, you have a result that is, to me, very intuitive, because the parameters are in the right order. But if you only make partial applications, it doesn't work this way, because the typing process will rearrange the parameter whether they're labeled or not. And we can't do this from the parse tree. We need what happened next to do it. So let's make a little demo. So can you read, first of all? No. Is it okay?
More.
Okay. I wrote a little example program, not very useful. So we are at the very beginning of the execution of the program. So first of all, we have the interpreted program. We are just right here at the beginning. And in its state, we have the pervasive module, which is a good beginning. Right under this, we have the source of the interpreter. And it is telling us that right now, we are running an element of module structure, which is lookable phrases, and it tells us that we will run an expression. This expression corresponds to the one just right here. So I can go forward in the execution of my program. It moves to the expression we want to execute.
So why does it say assert failure?
No. Okay, just wait a second. I'll show you. Don't scare me like that. Okay, the reason is because there is much more to see. Okay, so we are in the run expression function, which is pretty long because the code of the interpreter is over documented, because the goal of MLExplain is to understand the semantic of OCaml. So we have to go way.
Just go forward.
So we have the expression, and it will tell us that this expression is only a constant. So the constant will be executed and so on until we get a result. Maybe we can.
Can you show the code?
The code of. Yeah. Okay. So now let's say it is getting boring, right? So we'll go a bit further. We can put our cursor on part of the code and just go there with this button. And now it moved. And what can we see? We can see that in the state of our program, the x variable has been declared and is initialized, which is really good. So we could go on for much more time, and it's getting pretty boring. So let's go to the end of the execution for now. In the state of the program, every of our variable has been defined, and everything is executed. If we go to the interpreted states, we can see that we have a syntax object, which is the part of the AST that is currently executed. It can be unfolded on many layers. But more importantly, we have a result, and the result is the execution context of the program. And what do we have? Exactly what we wanted. So I finish the demo, if I can. The current state of MLExplain is that a large part of OCaml is recognized by our interpreter, except object part, because since OCaml has no actual specification, I haven't been able to fully understand how it works.
The objects are one part of the language that have papers written about them, and there is a documentation of what they do, fairly precise.
Okay. That's not really nice. And also recomp pattern, but only for a matter of time. If you have money and time for me, I can do it. So the most important conclusion on the current state of MLExplain is that the double debugger works like JSExplain. We don't like important features. And to finish it, the future works. So as I said, missing part of the language can be implemented with the help of Gabriel. And also, the generator has been improved in the development of MLExplain. Many parts that were complicated to write have been added to the compiler, so we could rewrite MLExplain to make it easier to read. I thank you.
Do you have any questions?
Yes.
So, one thing that I do often when I try to explain like a language that I have designed is show a program being reduced interactively in my presentation. You have the thing to reduce program interactively. Would it be possible to like just output everything needed to like make it easy to present to others in format? For presentation purposes, it's really.
You mean reduce? It's like small step
Yeah.
reduction semantics.
Yeah.
But this is like an external jar.
Yeah, exactly.
So this is the OCamlite.
It is.
Okay.
But I don't think of small step reduction semantics when I think about. Is that how you think about program in that kind of execution?
Not necessarily for OCaml, but in general, when I try to present a semantic or something that I wrote, I think small step is. Anyway.
Next question.
Why should I trust your interpreter?
To be honest,
I shouldn't.
because I compared every of, we made tests to compare what our interpreter outputs to be sure that it matched what the official compiler will output.
What does that mean?
For every part of the language, every time I try to execute it using my interpreter, I test that I get the same output using OCaml official interpreter.
There is no interpreter.
The compiler for you. Understand my
You look at the lambda code? I don't know. No.
You test it against the camel test suite?
No. So you look at the results.
Oh, okay. By hand, you execute the compiled code and you check that you get the same result. But would it be possible to extract an actual interpreter as a standalone executable so that I could substitute? I could use, for instance, to execute coq. It's an example. And would that work?
It should. Except, I expect it to fail somehow because maybe bugs or something. But in the principle, it should.
Next question.
How large is the subset of OCaml that your alternative ish OCaml? Like for instance, the thing I would be most interested in learning about, given that I'm fairly new, is the module language. I don't understand a lot of it. Could I step through some sort of complicated functor in the interpreter and see how that's implemented?
You mean the subset in which we wrote the interpreter? No. Or the subset that we wrote.
That I could debug with it.
As I said, we lack object part of OCaml, and the record pattern is not really.
But the modules and the functors, they work fine.
They should be.
Cool.
So I don't really understand the generator business. So you say it's a way to get traces. So would it have been possible to let people that write the interpreter also add some code to talk about the tracing? To say, oh, here you should trace this. Could I do it manually instead of using a compiler? And the sub-question is, maybe could I do it using a preprocessor, like a PPX, instead of having a compiler?
If you, okay, I'll take it in the right order. The generator takes FOCaml code, and during the compilation process, it will get the different function that will be called, and insert function calls that will log the.
But I could do it myself.
So you could do it yourself.
How much work would that be? Like, is it impossible or?
No, it should be totally possible. Using some aspect-oriented programming should be very easy.
And what about a preprocessor to do it on full OCaml programs?
May I answer?
If you want to, yes.
Because, well, we did that. We tried that initially.
Yeah.
And that really pollutes what you want to look at. Because if you want, we had a PPX that logged every function call, and that was way too much. So we couldn't really understand what was going on, especially since we're using monadic operators, and we log things differently between a monadic function call and between a normal function call.
But so this work reminds of PyPy, for example, which is exactly an interpreter that logs what it's doing. And in PyPy, people do it manually. They communicate with the logging system by writing some code in the middle of the interpreter. But it's just for JITting, so maybe they need less information than we do. But the intuition would be maybe it's possible to do it manually, or to do it with lightweight support of attributes.
So for OCaml, yes. For JavaScript, no.
Any other question? Okay, let's thank Kévin.